Previously, assignment was covered, and what we did was assigned to variables numbers. The next thing we want to do is something called iteration, and I'm going to motivate this by showing you an example of where we do an assignment operation many times. Suppose somebody told you that the population of an island doubled every year, and its initial population was 10. If I say p is equal to 10, this means assign to the variable named p the value 10. If I hit enter, MATLAB says I've assigned to p the value 10. And now if I want to know what happens next year, the population next year, I say assign to the value p a new value, which is 2 times the last value assigned to p, which is 10. So what I expect to see here is p is equal to 2 times 10, or 20. So when I hit enter, MATLAB says p is equal to 20. So now this is year 2. In year 3, I can say p is equal to 2 times p, and I should get 40. Now I know the population in year 40. Now in programming, quite often we find ourselves repeating the same command over and over. In this case, it's this equation. And what iteration does, and for loops do, is allow us to do this in a more compact way. Suppose that I wanted to repeat that operation 20 times. I wanted to find out what the population was after 20 years. I would have to repeat this command 20 times. P is equal to 2 times p, and so on. And iteration allows us to do that more efficiently. So let me open up an editor window here, and I'm going to repeat the commands that I just did. So p is equal to 10. I'm going to put a semicolon just so that it doesn't show so much output on the console. P is equal to 2 times p. P is equal to 2 times p. P is equal to 2 times p. And just to keep track of things and to remind myself of what I'm doing here, this is year 1. This is year 2. This is what it's going to be in year 3. And then I'll leave the semicolon off here at the very end so that I can see the output. And what's happening here is that I'm saying that in year 1 the population was 10. Year 2 the population was 2 times the previous value of p, which was 10. I'm doing it again here, and then again here. And everything after and including this percent sign is called a comment, and MATLAB just ignores that. It's as if I didn't type it. And so I typically put these in here just to help me read the program, and MATLAB just ignores everything after that, and including that percentage sign. Okay, so now if I execute this, I expect that it's going to compute a population, and it's going to tell me the population in year 4. So I hit this play button, and actually before I do that, I'm going to hit the clear button. I'm going to type in clear just to clear all memory of variables for good measure. It's always a good habit to get into. And it tells me that it wants to save this as a file. And I can give this a name. I'm just going to call it rabbits because rabbits populations tend to increase very rapidly. Save it, and now it's ready to run, and it's just run. You see the output here. I can run it again, and you can see what's happened is that it just prints out p is equal to 80. And sometimes it's convenient to clear the screen. There's a shortcut command that's CLC, which means clear console. And then if I go back to my editor, I'll add that up here. And now I type clear CLC, and now every time I run this program it clears the console, and then it just shows me what the value of p is. If I get rid of this, it should show me the two most recent values of P, 40 and 80, and so on. 3 values, and now it'll show me the year 1 value. Okay, so I said I want to do this. Let me just do it for 10 years. And I'll just keep notation here. Year 5, year 6, year 7, year 8, year 9, and year 10. And I won't print out anything until the very end. And here's the result of my calculation. P is equal to 5120. And as I said, oftentimes is the case you'll want to know, say, the population in after 100 years. Or you'll want to do the population in 1,000,000 years, effectively. It all depends on the equation that you want to iterate. We won't always be solving population equations. We may want to be doing an equation that tells us how the balance in a bank account grows, for example. And in that case, we might want to compute the balance every day or every month. And in that case, we're going to have to do many, many repeats of a similar equation, like we're doing here. And so what iteration allows us to do is to write this in a shorthand notation. I'm going to do this here. And the first thing you do when you have a program that looks kind of long is you look for the part that's repeated. The part that's repeated that MATLAB reads is this. Again, MATLAB doesn't read this. And so from MATLAB's perspective, this program has 1, 2, 3, 4, 5, 6, 7, 8, 9 repeats of the exact same equation. And a for loop allows us to write that in a compact way. And here's the notation. For I is equal to 1, 2, 3, 4, 5, 6, 7, 8, and I said I did it 9 times, right? Time number 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And so the syntax, which I'll explain shortly, instructs MATLAB to repeat everything inside the blue for and the blue end 9 times. Okay, and so this is an equivalent program. MATLAB interprets this as being repeat this thing 9 times. And now you're probably wondering why I chose this and why I chose the numbers 1 through 9. This is called an index variable. And whenever you do a for loop, it actually keeps count of how many times it's repeated the for loop. In addition, at each step of the for loop, it will assign to a variable named I a different index value. So actually the equivalent program that's being executed here is not identical to this. It's identical to this. I is equal to 1. I is equal to 2. I is equal to 3, and so on. So I wanted to shorten the number of statements that I needed to make. I use this shorthand notation here, and in addition, I found that the program that I created has an equivalent program where it's actually internally it's setting a value to I. And it just turns out that I never used this. So if you looked at this program, you would read it as this. Assign to P the value of 10, assign to I the value of 1, assign to P the value of 2 times P, and so on. And you would look at this and say, well, why did you do all that with I? And the answer is that in this particular case, we don't need it. We don't need all these lines with I equal to 1, I equal to 2. But eventually we will. And so when you see a for loop like this, just keep in mind that what it does is it repeats everything between the for and the end over and over, and before it does it, before it repeats that command, it sets this counter variable equal to these values. So the first time it repeats it, it sets I equal to 1, the second time I equal to 2, and so on. So let me run these two programs, and what I'm going to do here is suppress the output for the first case. I'll type in P here, and now what's going to happen is MATLAB will execute these commands, and because there's a semicolon at the end, it won't output any information. And here I've just said, tell me what the value of P is at this point. And I'm doing the same thing here. It's going to repeat this line over and over. And if I type in P here, it's going to tell me what the value of P is after it's done it 10 times. So everything here, between here and here, between here and here, is identical to everything between here and here. And so to make these two programs actually identical, I need to do this. Clear CLC. And now this is the part that I couldn't do with a for loop. And all of this stuff is equivalent to the lines here between 27 and 29. And so when I run this, I should see this screen clear, and then I should see two values of P printed out. The first value will be associated with executing this program in longhand form, and the second will be associated with executing effectively the same program but in shorthand form. And so what's happened is actually, let me get rid of this second CLC because it's clearing the console twice. I'll do that. And so now every time I run this, it executes this, clears all the variables, and here I didn't clear the console because I wanted to keep this thing in view. And so now when I run this program, I get identical values. And I can verify this. If you want to do it the old way, I can just copy this, paste this. It's going to execute all those commands. It tells me P is equal to 5120. Now I can copy these commands as well, paste them in there, hit enter, and I get 5120. So next thing you should think about is, now that I have this shorthand, what would happen if I change this to, say, start at 2 and go to 10? Well, in this particular case, we never use this variable I. And as it is up here, if you look at this program, if I started here with I equal to 2 and went up to I equal to 10, my calculation for P wouldn't change. And this is a case where we're calling I a dummy variable. It's not really being used. Later on we'll use it, but in this particular program it's not being used. So the key thing to remember is that everything between the 4 and the end is repeated as many times as there are numbers here. And I'll show you later how to write this particular part in a more shorthand notation. But for now I'm going to leave this in the longhand notation, and what you need to remember is that this part, this middle part, is going to be repeated as many times as there are numbers between the two square braces. And let me just show you that you get the same result. So I run it now between 2 and 10, and I still got the same answer.